Welcome everyone. Uh, uh, Today is the session number 20 of NEET Physics, and I have again taken one question which was asked in the, I think it was either asked in the CBSE All India Pre-Medical Test or in the NEET examination. So ये एक क्वेश्चन है जिसमें लिखा हुआ है कि the potential energy of a particle in a force field is given by U is equal to A upon R square minus B upon R, where A and B are constants and R is the distance of the particle from the center of the field. So the distance of the particle for stable equilibrium क्या होगा? See, for the stable equilibrium, the rate of change of this potential energy with respect to the distance of the particle from the center of the field should be equal to 0. That is du upon dr. ये आपको 0 होना चाहिए. So अगर हम इसका du upon dr निकालते हैं, ठीक है, ये आपका हो जाएगा a इज अ कांस्टेंट है, सो 1/r² है, तो 1/r² को अगर हम फर्स्ट ऑफ ऑल आई विल राइट दिस u लाइक u इज इक्वल टू a r टू द पावर -2 हो जाएगा माइनस b r टू द पावर -1. सो du अपॉन dr क्या होगा? ये कांस्टेंट है, ये हो जाएगा आपका -2 r -3, ठीक है, और दूसरा हो जाएगा आपका ये आपका b कांस्टेंट है, ये आपका हो जाएगा -1 r -2, ठीक है. सो नाउ फॉर दिस स्टेबल इक्विलिब्रियम दिस हैज टू बी इक्वल टू 0. ये 0 हो जाएगा. सो आपका आंसर यहाँ पे ये आ जाएगा कि दैट इज -2a डिवाइडेड बाई r³. ये जो r-3 है इसको मैंने नीचे ले लिया, ये आपका माइनस माइनस प्लस हो जाएगा, तो विच इज इक्वल टू b डिवाइडेड बाई r² एंड दिस हैज टू बी इक्वल, दिस विल बी इक्वल टू 0. So it implies that ये आपको हो जाएगा -2a. I'm just multiplying this whole equation by r³ on both these sides of this equation, so we will be getting is -2a plus br is equal to 0. So it implies that br will be equal to 2a, यहाँ चला जाएगा 2a, और r will be equal to 2a divided by b, ठीक है, 2a divided by b. So the correct option is b, that is for the stable equilibrium the distance of the particle from the center of the field will be equal to 2a divided by b. So मेरा ऑप्शन जो करेक्ट ऑप्शन है वो है आपका b, ठीक है. So this is how you have to do it. For the stable equilibrium, the means what you have to remember is that du upon dr will be equal to 0, ठीक है. So इसको हमने जो ये आपका जो आपका दिस इक्वेशन दिया हुआ था, that is the potential energy of a particle is given by this u is equal to a divided by r² minus b upon r. इसको मैंने जो है I have just differentiated u with respect to r and then I have equated it equal to 0. So उससे हमारा ये r की वैल्यू आ गई, and this r is the distance of the particle for stable equilibrium, ठीक है. So now let's move on to the second question. Now the second question, this question which I am going to write right now here was asked in the CBSE All India Pre-Medical Test in 2005, and here the question is, this is the force in newtons. This is the force in newtons, and uh, this is the x-axis, this is the y-axis, this is the origin, and this is along the x-axis. It is the uh, the distance is given, okay, and along this y-axis the force that is which is in Newton is plotted. So यहाँ पर एक इस प्रकार का प्लॉटिंग है, 1 2 3 1 2 3 4 6 7. So this distance is in meters, and yeah. So this graph is basically showing the the uh, the variation of the force with the distance on an object. So this graph is basically showing the graph is showing the variation of force with the distance of an object. ठीक है. So इस केस में यहाँ पे लिखा है a force F is acting on an object. The force F is acting on an object which varies with the distance as shown in this figure. The force is in newtons and the distance is in meters. We have to calculate the work done by the force in moving. Work done by the force in moving from x is equal to 0 to x is equal to 6 meters is, पहला ऑप्शन दिया हुआ है 4.5 जूल्स, बी है आपका 13.5 जूल्स, सी है आपका 9 जूल्स एंड डी है आपका 18 जूल्स. ये चार ऑप्शंस दिए हुए हैं. सो वी हैव टू फाइंड द वर्क डन बाय द फोर्स इन मूविंग work done by the force in moving this object, in moving the object from x is equal to 0 to x is equal to 6 meter. So in this case we know that the work done is equal to applied force into the displacement. ठीक है. So यहाँ पर अगर आप देखेंगे यहाँ पे force ये it is represented along the y-axis and this displacement is along the this x-axis. So यहाँ पर जो आपका ये जो अंदर एरिया है that is the area enclosed by this curve. Let us say this is O, ये point A ले लेता हूँ, ये point B ले लेता हूँ and this is the point C. So the area enclosed by the curve, that is curve ABC, ये जो है that is the area enclosed by this curve will be equal to the work done in moving the object from x is equal to 0 to x is equal to 6 meters. ठीक है, बिकॉज नाउ ये देखिए फोर्स है, दिस इज द फोर्स है ये आपका, दिस वाई एक्सिस के लॉन्ग में ये आपको दिस इज 1, 2 and 3 न्यूटन्स. ठीक है, सो अगर हम एरिया निकालते हैं, फॉर एग्जाम्पल ये पॉइंट मैं ले लेता हूँ डी, सो ए बी डी ओ, सो यहां पर द एरिया ऑफ दिस स्क्वायर दैट इज ए बी डी ओ, ये कितना हो जाएगा, this will be equal to this is 3 and this is 3, so this is equal to 9. ठीक है, और ये कितना हो जाएगा, that is area of BDC, this will be equal to half into base कितना है 1, that is equal to 3 and into 3 which is equal to 9/2 हो जाएगा, which is equal to 4.5. ठीक है, so the work done कितना हो जाएगा, work done in moving the object from x is equal to 0 to x equal to 6 meter will be equal to 9 plus 4.5 which is equal to 13.5 joules. ठीक है ना, so this is how you have to do this question. Here simply you have to find the area enclosed by this curve, ठीक है, and the area enclosed by this curve will give you the work done by the force in moving this object from x equal to 0 to x equal to 6 meter. ठीक है ना, अब ये भी देख सकते हैं यहाँ पे क्या है, इफ यू आर जस्ट अगर आपने एरिया लिया है, फॉर एग्जाम्पल ए बी डी ओ का मैंने एरिया लिया है, तो क्या है, व्हाट इज दिस, वी आर सिंपली मल्टीप्लाइंग द मैग्नीट्यूड ऑफ दिस फोर्स बाय दिस डिस्प्लेसमेंट. ठीक है ना, 3 into 3. ठीक है, तो ये आपका एरिया ही हो गया बेसिकली. सो इफ वी सिमिलरली इफ आई जस्ट कैलकुलेट द एरिया ऑफ दिस फिगर, तो क्या होगा, दिस विल बी गिविंग यू द टोटल वर्क डन इन बाय द force in moving this particle from this x equal to 0 to x equal to 6. So the work done हमारा हो जाएगा 13.5 जूल, और यहाँ पर जो करेक्ट ऑप्शन है वो मेरा है B, that is यहाँ पे B में दिया हुआ है 13.5 जूल. So this is how this question has to be done, and so in the next session again I will be coming up with a couple of questions from the same chapter. So till then, have a nice day, bye.